Okay, so you should have a copy there of 3 sample questions. We're only going to be looking at the first 2 today because the third one is a vertical sample. And vertical circular motion is sort of a whole new beast. So we're just going to look at the first 2 today. So the first one says, an object of mass 1.5 kilograms is tied to the end of a string 0.5 meters long and is swung in a horizontal circle. So when you're doing these problems, one of the first things you want to do is just make sure you know whether it's horizontal or vertical, because completely different scenarios. Okay, so horizontal circle with UCM, such that it makes 5 revolutions in 4 seconds. Find the frequency, the period, the speed, the AC, 2 different ways, and the tension in the string. Well, that's a good point that you brought up, then, Zach. We'll have to make sure we know what they mean. What does frequency mean? Frequency refers to the number of revolutions per second. How many times does it go all the way around in 1 second? Okay, now the best way to sort of do it, the way that I recommend, is to set up a little ratio. If it makes 5 revolutions in 4 seconds, and frequency is number of revolutions, so I'm going to put my X on top, in 1 second, right? It's just a basic little ratio kind of thing. Cross multiply.
20.
And what are you going to end up with here? You're going to, if you cross multiply, you're going to have 4x equals 5. What do you know? It's 5 divided by 4, right? Yeah, it's just divided. So that's going to give us 1.25. Now, does anyone happen to know the unit for frequency? Hertz is correct. Just like the rental car. That's actually HZ. If you look on the back of computers and whatnot, when they talk about like megahertz and gigahertz and stuff like that, that's what they're talking about. They're talking about frequency. How many cycles per second? How many equations can it solve per second? 1.25 hertz. Now, what is the period? How are period and frequency related? Cody, do you know?
Oh,
No, you know? I know it's never actually specific. Period is the time it takes for 1 revolution per second. So it's in fact the opposite of frequency. Okay? You could do it this way. You could say 5 revolutions in 4 seconds. So we want to know the time. So this time we put the X on the bottom, and it's 1 revolution. Cross multiply, you're going to have 5x equals 4, and x is equal to 4 over 5.
So it's time for one.
It's 0.8 seconds. Now there's a relationship between, a mathematical relationship between frequency and period. It's the inverse, exactly. 1 over t is equal to f. The frequency is 1 over t, and vice versa. The period is 1 over f. Okay, well, look at it. 5 over 4, is that not the inverse of 4 over 5? It is. Okay. Now, you're not going to see a whole whack of questions like that on the test, obviously. That's just sort of, you might get asked one of them. Which one appears in the formulas that we looked at yesterday? T or the F? T. So it's probably better off for you to find T than frequency. Although I will show you in a few days that there are some, we can rearrange the formulas so they have frequency in them. All right. So the next step here, I've got A and I got B. I need to find the speed. I need to find speed. So a formula from yesterday that has V in it. Help me out here. I'm sort of flying without my notes here. Formula from yesterday that has
C equals mv squared over r.
No, I did A and B. I did frequency and I did period. This one's A. This one's B.
There's only 2 with B.
How am I going to handle the velocity? Well,
Not velocity.
is velocity not equal to distance over time? And the distance it travels is actually the circumference. And circumference is equal to? No, that's area. 2 pi r. 2 pi r is the circumference. And the t is, that is an equal. And the t is actually period, big T.
Wait, little t is time and big t is period.
Right.
I understand. No, the time is the time period.
Yeah. Big T is just the time for one revolution, right? So we've got 2 pi. Now the radius of this circle is, it's a 0.5 meter long string. So that's going to be 0.5. 2 times 0.5 is 1. So that's basically pi on top. And our period we worked out to be 0.8, right? And so you get 3.93 meters per second. 3 marks to there, right? Really?
4.
Well,
Probably 5.
I don't know. D is to find the what? Acceleration, but you got to do it 2 different ways. Now, the only reason I do it 2 different ways is because I just want to show you the use of the formulas to show you that you can, yeah.
Question.
Yeah?
Would be sometimes where you only use one or the other.
Yeah, it depends on what you know already, right? Yeah.
And you might not ask this question in order to, so you might just pull it.
That's right. So I'm going to have v squared over, now, for some silly reason, I tend to switch from little r to big R. So if I do that, it's not for any particular reason, it's just random. Yeah, it's just a bad habit I've picked up along the way. Okay, so I'm going to try and keep it as little r, but if I happen to throw a big R in, it doesn't mean anything different.
Why?
Because I don't know why I do it, I just do it, I guess. I think I must have learned this formula with a big R in it once, and I just can't get it out of my head. Yeah. So I'm going to have 3.93 squared all over the radius, which was 0.5, I think. 30.9 meters per second squared. And what direction is that acceleration?
Inward.
Inward, right. You will find that the acceleration tends to be a big number because it's changing its direction quite dramatically, right? Because it's going in a circle, right? Okay, so that's the first way. The second formula that has acceleration in it is 4 pi squared, and here's where I always want to put the big R, all over t squared. This is the formula that I suggested yesterday, and Zach, I'm going to say this for your benefit as well as a review for others. Be careful here because we're all familiar with pi r squared. It's pi squared r. I can't change it. 4 pi squared r over t squared. Four pi squared, the radius is 0.5, t squared is 0.8 squared. Now, can you do that all at once on your calculator? You should be able to. I think when you actually do it, I think you get 30.8. I think there's a little bit of a rounding error in there, but you should try to use the pi button on your calculator if you can. Try to use the pi button rather than 3.14. Just to get a little more precision.
3.1415.2654.
That's the one. Or you could just memorize it too, I suppose.
Well, keeps going forever, so. No?
Last thing now, the tension in the string. Now, what do I mean by the tension? Yeah, force outward. Tension is simply a force. And so what we're really asking for is, what's the centripetal force?
FC equals mv.
Yeah, it's just Fc. Now there's about 3 different ways you could do that. You could say Fc is equal to
Mass B.
MAC. In other words, take mass. What was the mass here? 1.5 times your 30.9. If I haven't asked you for A already, well then of course you could use Fc is mv squared over r. Yeah, from yesterday, right? Remember, mv squared over r is just v squared over r with an m in front, right? Because F equals ma. Or of course, there's the other one, m4 pi squared r all over t squared. Any three of those are going to give you your correct answer.
Can we use any formulas other than A equals B squared over R, AC equals 4 pi R,
Nope.
squared of R, over B squared,
Well, I use circumference here, 2 pi r.
C equals MB squared over R, RC M 4 pi R squared.
Okay, why are these like pretty much the same acceleration ones?
Because acceleration, or force is just mass times acceleration, right? So you take the ones for A and simply multiply by m, that's all.
Oh.
But I don't know what you
How do you
do.
get, how do you get 46.2? I got 0.35.
I got 0.33.
I don't know.
You're wrong.
Whatever. Something like that. Oh, sorry. Sorry. Whatever.
Um,
Okay.
Put 30.9.
so
40 yes.
46.35.
3-5, says Stefan? Okay.
Alright, I truncated. I didn't truncate on that. Masticated cartridge. Realize.
Remember, we're only going to do 2 today, right? Okay, so number 2 is a little different. A string can withstand up to 7.5 kilograms hung vertically on it, and then it breaks. A piece of string 4 meters long is used to roll a 2 kilogram mass on a horizontal surface faster and faster until it breaks. So I've used the word vertical and horizontal in there.
Uh-oh.
Wow, so you got to read a little more carefully.
I like it.
I've also got a 2 kilogram mass and a 7.5 kilogram mass. So what the heck's going on here?
One's vertical, one's horizontal.
One is vertical, one's horizontal. It says a string can withstand up to 7.5 kilograms hung vertically on it, and then it breaks.
So like,
So all they're telling you is how much force will break the string. Then they stick a 2 kilogram mass and they whirl it in a horizontal circle.
perfect.
So that's kind of just a loop.
Well,
The loophole.
it's just a way of giving you the maximum force. You know when you go fishing and they tell you how much the line will hold? Same idea, right? Okay, so your first step here is to find that braking force. And it's simply a weight force, right? 7.5 kilograms down, how much force is that? 7.5 times 9.8, 73.5. Newtons, thank you, Zach. So 73.5 newtons of force will break the string. Now, find the maximum speed reached before breaking. How fast, oh, I don't have one here, how fast can you whip it around before the string breaks? Because the faster it goes, the more tension, right?
Plug that force in there.
Well, what's our formula that has force and velocity in it?
Force and velocity.
MC equals mv squared.
mv squared over r. mv squared over r. And we're going to put what in for our force? 73.5, because that's the braking force. That's the force that will cause the string to break.
Good math.
Now, which mass do I use, Steph?
The 2 kg.
How come?
Because it's the one we're spinning it.
That's the one where you spin. The 7.5 already broke the string, right? So put a mass in there.
What's the difference?
And it's a 4 meter long, that's pretty big, isn't it? That's a big string.
60 feet long.
So that's going to be the,
Again, 2 kilograms is pretty heavy to swing around.
yeah,
But this guy's pretty
you're going to need a couple of guys, I think, to, yeah. 4 times 73.5 all over 2, I think, right?
Yep. 2, 4,
I get 12.1?
5, 6, 5.
Is that a negative?
No,
73?
no, shouldn't be. 12.1 meters per second. Now, interestingly enough, this is a velocity, but are you ever going to get a negative value out of that?
No.
How can you when it's a square root?
That's true.
Yeah.
Okay, so
Okay, so 70
I went 4 times,
And then divided by 2.
I took the 4 up here, right? Took the 4 up there and multiplied,
divided
and then divided by the 2,
by root.
and then took the square root. Yeah, you're good? You want me to show that stuff?
Yeah, I do that.
Really? Yeah, is that?
Yeah, I know that.
But you're shaking your head no.
No, yeah, yeah. So you just move the four over.
Oh, gotcha. Are you showing every step? No, you do it twice. You do it twice.
Okay.
No, you do it once.
That makes sense.
Oh, you're an idiot. Show the process. It is like-
So the maximum speed before braking is 12.1. Now, what is the period of motion at brake time? In other words, how long does it take to go around when that string breaks? Where's my, All right, so which one's going to have period in it? I think we've got T equals 2 pi R over V, right? So 2 pi, the radius was 4, I think, wasn't it? And our velocity, 12.1. I get 2.08 seconds. Yeah, you get hit with a 2 kilogram mass traveling 12 meters per second.
Equal or that?
You get, that's gonna smart. I'll leave a mark. Alrighty, so you've got a worksheet here with some questions on it. I apologize, I don't have the QR code quite ready here, but we're not having a lot of success with them on phones, are we?
No.
I use them.
It works for you? Doesn't it scroll all down or something?
Yeah, he told me how to say.
Oh.